All right, so we have 2 lessons. We're going to do 12.3a first. All right, so 12.3a, we're going to talk about, we're going to focus on just 2x2s, okay? Just 2x2s. On Monday, we'll do 3x3s. So 2x2 matrices, and we're going to learn all about finding the inverse. Okay? We're going to find the inverse, and I'm going to walk you through all the steps, and we're going to put them all together to find the inverse of the matrix. First of all, we need to know some quick definitions in order to do these problems. Okay, so here's the thing about an inverse. Not all matrices will have one. The only types of matrices that are going to have one are square matrices. But even then, not all square matrices will have an inverse. So what does it mean to be a square matrix? What do you think it means to be a square matrix? So a square matrix? Like the shape of it. Like if it's a matrix, it's a square. Is a 3x2 a square matrix?
No. It would be like 3x3, 4x4.
Perfect. Yep. Exactly. So the number of rows equals the number of columns.
You want me to teach it?
You know, I get paid to do this a little bit. Not much, but a little bit. So I should probably do it. Oh, that's cute.
It's not exactly a stripe.
So 2x2 is an example. 3x3 is an example. Yeah, I am. 4x4. Okay, 100 by 100 is a square matrix. We're not going to do those, of course. That's just silly. All right, the most we will do.
The test should be one problem, and it's like 1,000 by 1,000.
Ooh, that would be rough. And it's either pass or fail. That's not good. All right, so we're going to do 2x2s today and 3x3s on Monday. Okay, so we also have something called the multiplicative identity. I know that sounds like a very fancy word. Multiplicative identity. And you've actually learned about the multiplicative identity way back on the first day of school. First week of school. When you do real numbers, and if you take any real number times 1, you get that real number back, right? That's pretty obvious. Anything times 1 equals it. Well, with matrices, it has a multiplicative inverse. So we call it matrix I. And they're different for whatever size you want. So for a 2x2, we call it I sub 2. The multiplicative identity, it's like the matrix C equals 1. Okay? It's this matrix. 1, 0, 0, 1.
That's kind of dope.
Yeah. So if I take any matrix that I'm allowed to and multiply it times that, I will get my same matrix right back. Yeah. If you were going to do this for a 3x3, this is what the identity matrix looks like for a 3x3. It's 1, 0, 0, 0, 1, 0. What do you think the last row is?
0, 1.
Yep, 0, 0, 1. Okay, so if you notice, it's the diagonal going this way, not going the other way, but only going this way. This is, everything else is 0.
So the next one feels 4.
Yep.
It'll be 0, 0, 0,
1 at the very end. Yes, that's right.
It's always like that?
Yeah, always. And so if I were to take, any matrix and multiply it times these matrices, I'll get that same matrix back. It's like the number 1 in the matrix world. Okay, now one more thing. We have something called the multiplicative inverse. Multiplicative inverse. Okay, we're going to learn how to find an inverse of a matrix today, and that might be kind of weird. We found inverses of like the function f of x. Remember we found f inverse of x? It's the same kind of thing for matrices, but this is what happens. If you have a matrix A, and you multiply matrix A by its inverse. Okay, now think about what inverses are. Like if I took 2 and I multiplied that by its inverse, which is 1/2, what would I get? 2 times 1/2, 1. 5/7 times 7/5, 1. Anything times its inverse for matrices will give us one of these identity matrix. We're talking about square matrices, okay?
Only squares.
Mm-hmm. Yep. All right, so here we go. The first couple of problems you're going to get in your homework tonight are going to look like this. Number 1, we are going to verify or show, okay, sometimes they say show, that A and B are inverses of each other. Are inverses, okay? We're going to verify that A and B are inverses of each other. Now here's what you're supposed to do, and I'm going to make it a little easier on you. You're supposed to show that A times B equals the identity matrix, and that B times A equals the identity matrix. But I'm not going to make you do both. You just have to do one way. Just one way, okay? So we're going to show that A times B equals I. Yeah. Some people had a little problem with that. Like, no, we're supposed to show both ways. Yeah, who cares? All right, so here we go. Let's say that matrix A is given to us as 2, 3, 1, 2. Okay? And matrix B, I'm just going to write it right next to it so that we can multiply them. So this is going to be matrix B. B is 2, negative 3, 2, negative 3, negative 1, 2. And we're going to verify that those are inverses of each other. I don't like something. I'm going to erase that, and I'm going to write it under here. Okay? All right, so this is A, that's B, and I'm going to multiply them together. It's kind of like a proof in a way. I know you hate proofs, but we're going to, or maybe you don't. Does anyone like proofs? Proofs. Remember from geometry you had to do proofs? Yeah.
That was so dumb.
It's hard, huh? That's how like.
What's the purpose of that?
It's really just to like practice your organization like skills. You have to prove a lot of stuff in life, right? Anybody want to be a lawyer?
Proving no stuff like that.
Probably not. Okay.
Oh, yeah.
Yeah. Remember those?
Prove that you got this stuff.
You had to prove that the triangles were congruent. Yeah.
Right
Right?
there. I feel like I just.
You have to prove it though. It's hard, huh? What? That's how higher level math is. Once you get past calculus, it's all proofs after that. Really hard. Okay, so here we go. We're going to multiply these two matrices together. Now, you're really good at multiplying matrices, am I right? Pretty good? Most of you? I'd say 99% of you. Yeah. And the other 1%, we got to catch up here. Here we go. We're going across and down. Make sure that you show your work, okay? 2 times 2, the first number times the first number is 4, plus 3 times negative 1. Okay? You should be getting pretty good at these by now. Let's do the next one. We're going across the row and down the column. So 2 times negative 3 is negative 6, plus, bless you, 3 times 2 is 6. Is everyone following this pretty good?
That's 0.
Yeah, we're going to fix that in a minute. All right, now we're going to go to the next one. We've got to wait. Across and down. So 1 times 2 is 2. 2 times negative 1 is negative 2.
Wow.
And then one more time. Across and down.
Wait.
1 times negative 3 is negative 3. 2 times 2 is 4. Are you doing them different colors too? It's really cute that way. Okay, now here it comes. This is the part where you love because then you can see that you got it right. What do we get up top? We get 1, 0, 0, 1.
Wow. Wait.
So good. That's what we wanted to show. It is.
No, that's like.
They're only,
You get, it's always going to be.
if they're inverses and we're proving that they are, when you multiply them together, you will get that.
So no matter how big the numbers.
Yep. Yep.
No matter how many
Right.
numbers.
You try this one. You try it.
Actually,
Take this matrix, negative 2, negative 5. You don't need to use different colors on this one, or you can. Negative 3, negative 8. And you practice this. You multiply it times negative 8, 5, 3, negative 2. Okay? So hopefully you're pretty good at multiplying matrices. And then we'll see what you get at the end. But show your work. Show that middle step. Okay? On all of these problems. All right. What did you get? What do you think you got? What were you supposed to get?
1, 0, 0, 1.
Yes. So 16 minus 15.
Okay, question.
Yes.
So So what if I get to the quiz and just write 1?
No, because it's like that. Yeah, that's a really good question because that comes up a lot. If you just write 1001, it's not a proof. You're proving it by showing your work and your steps. It is the right answer, but sometimes, just like I told someone in my last class, you get the right answer doing the wrong thing still gets you -1 on the quiz. Yeah. All right, 1001. All right. No, literally, someone just got the right answer on their quiz, and I'm going to mark them off because their work was wrong. Okay,
So
here we go.
What if I only wrote the answer you marked me off?
Yes.
That's really.
You should know about it to her.
Do we have to write out the addition too?
Yeah, I need to see this step right here.
So we can just write out. No, wait, nope.
You can't just write 1001. You have to write the middle step and then show.
Just put the middle step.
No, because then you gotta finish it. All right, now we're gonna talk about the inverse of a matrix, okay? So here we go. We're gonna first find the first part of an inverse, and we're gonna find something called the determinant. Now, a determinant of a matrix, basically it determines, right? Determinant determines if the matrix has an inverse. Yeah. But it's pretty good, and you might have some time to work on it right now. Yeah, next week. Now, this is how you find the determinant, or this is how determinant determines if you have an inverse. So let's say we have matrix A, and we're trying to determine if matrix A has an inverse. So what we do is we find the determinant. And the determinant of A, if it equals 0, there's going to be no inverse. Okay? Every other number is fine. -3, bless you, 10, 100, 1/2. Any other number is perfectly fine. Just if it's 0, it's not going to have a determinant. Now, how do you find the determinant? Okay, so here we go. Let's say you have matrix, we'll call it A again. And matrix A is, we're just doing 2 by 2s, okay? And matrix A is A, B, C, D. So those are going to be numbers. And here's how you find the determinant of matrix A. The determinant is going to be a real number, okay? Just one number. And it's pretty easy to find. This is what you do. You're going to take A times D, okay, minus B times C. That's it. Adorable, right? Isn't that so cute? I know. That's how you find the determinant of A. I did that in different colors so I could watch you guys switch pins. Okay, so let's do one. Here we go.
The red didn't do it at all.
It didn't help? No, you can put that in black. That would probably look better in black. Yeah, it totally does. Okay. Here we go. So, number 2. Find the determinant of the matrix. So, let's say that our matrix is -3, 4, 2, -5. Okay, we're just doing 2 by 2s. Okay, finding a 3 by 3 is different. We're going to learn that on Monday. But right now, 2 by 2s. So all you do is start in the left-hand corner and multiply the diagonal numbers together. So what's -3 times -5? 15. I almost spoiled it for you. And then subtract, multiply the other diagonal together. 2 times 4, 8. So the determinant is 7. That's it. All right, you try one. You try this one. -4, 2, 3, -6. You try this one. Find the determinant of that matrix. Okay, it gets a little tricky. You got some negatives in there. It's okay. You're gonna be all right. You multiply the diagonal this way first. So you get -12 minus -12. Haha. We got that the determinant was 0. Okay, the determinant equals 0. Now, in this case, this one would not have an inverse. And you're like, how do we find the inverse? We're going to do that next. Do you feel pretty good about determinant? You don't need any more of those. Okay, here it comes. Here's how to find the inverse of a matrix. So we're going to go back and we're going to let matrix A equal, bless you, A, B, C, D. Still that same matrix. Okay? And if the determinant of A does not equal 0, then here's what the inverse is. A inverse. Do you remember that notation? A to the negative 1, that means inverse. A inverse equals this. 1 divided by the determinant of A. First of all, let's pause right there. Do you see why the determinant can't be 0?
Yeah.
If it was 0, we would be dividing by 0. We're not allowed to do that. Okay. So 1 over the determinant of A, and here comes the funnest thing you'll ever do in math. Here it comes. You ready? I'm not kidding. We're going to take A and D, we're going to pick them up, and we're going to switch them. Right?
B to the A first.
And then B and C, guess what? They stay put, but they become the opposite of what they were. So good. That's it. That's how you find the inverse of a matrix. You're probably wondering, why would we want to do that? Well, that's coming up in a minute. Right now we're just doing, and then we'll finally put it all together at the very end.
I have to remember that.
It's like the dessert.
Like
Yeah.
memorize that.
Yep, you got to know that.
Sure.
It's not rude. It's basically this. It's 1 over the determinant. You take these and you switch them, and these become opposite. Okay, that's another way to think of it, without all the letters in here. Switch, opposite, opposite, 1 over determinant. So let's do one. Number 3. We're going to find the inverse of the matrix. Okay? We'll do a couple and see how you do on these. So here we go. Letter A. Let's say our matrix is M for matrix. And matrix M looks like this. -2, +2, 5, -4. And we need to find the inverse of M. Okay? It's just a little something you got to memorize. Like a little formula that you got to do, right? It's not hard, not too bad. First thing you got to do is find the determinant of M. Okay? Because that determines. If you get 0, guess what you get to do? Yes, nothing. You get to stop and move to the next problem. You're like, sweet, no inverse. Yay, easy problem. I don't do that a lot, though. All right, determinant of M equals 8 minus 10. You got that pretty good? 8 minus 10. That's the first part of the routine. Yeah. And then you get -2. Okay, so we're going to go 1 divided by the determinant, which is -2. By the way, some people think the determinant is 1 over -2. That's not true. The determinant is -2, and it goes in the bottom. And now we're going to do the funnest part ever. You're going to pick up 2 numbers, and you're going to switch places. Crazy, right? Are you looking at my kids? No? -4, -2. -2, -5. Those stay put, but they become the opposite. And then finally, your last step is to take that constant and multiply it into your matrix. What do we get? 2, 1, 5 halves, or 2.5, whatever you prefer. I like fractions over decimals. And 1. That's it. How good is that? Did you like it? Yeah? You're pretty good? You try one now.
Better than whatever we did last chapter.
Yes, last chapter was rough, wasn't it? Yeah. All right, you try this one.
Mostly faithful.
Matrix A equals 3, 9, 2, 6. And I want you to find A inverse. What are you doing?
Try and check that.
No.
You silly.
First, find the determinant, which is 18 minus 18. 0. Oh, yay. That one's a good one. Does not exist.
Love that solution.
Shut up. Okay, let's see. No, you try a real one now. Here we go.
Okay.
Okay. Try this one. Let's see. Oh, let's call it something. Let's call it matrix C. C equals -2, -5, 1, 3. All right, you try this one. Let's get real. This is the last one, and then we're going to move to our last lesson. It's pretty quick today. Pick them up and switch them. 3, -2, +5, -1. Those stay where they're at. They become opposite. And then don't forget to actually multiply that determinant in. It's just -1, so you just flip the signs on everybody. Anybody get that? Yeah? Yeah? Okay, good. Okay, now we're going to take everything we've learned and we're going to now apply it to a problem. Are you ready? Here we go. 12-4A. 12-4A. We're more than halfway done. We learned most of it,
Should I
okay?
get a new piece of paper?
No, keep going. It goes really well together. Now we're going to solve 2x2 equations. Okay? Solve 2x2 equations. We have 2 parts to this. What? Oh, golfing already at 10:30 in the morning? Where are you going? Okay, so here we go. We have 2 parts for this lesson. Part A, we're going to solve matrix equations. So you've already solved matrix equations. Remember your quiz you just had? You had x plus a matrix equals. You had to subtract the matrix to the other side. Okay. Now the thing is, there's no such thing as matrix division. So when you get a problem like that, it's really hard to solve because you're like, wait a minute, I can't divide by a. Like if I asked you to solve 2x equals 10, but you're not allowed to divide, you can do that. You're so used to dividing by 2, right? But what if you multiplied by 1/2 instead? So that's what we're going to do
What's the point?
to solve for x. So we're solving for this x right here, but we can't divide by a. So what we're going to do is we're going to take the inverse
Oh.
and multiply it. Now be very careful. You have to multiply it on the left side of b. Over here with this number 1/2, I could do that because, 10 times 1/2, same thing as 1/2 times 10. But in matrix land, A inverse times B is not the same as B times A inverse. So make sure you do that. And then what you get here, remember we just showed this. When you multiply 2 inverses together, you get that special matrix, 1, 0, 0, 1, which is just the 1 matrix. So you just get x. It's like they cancel each other out. X equals A inverse times B. So that's going to be our goal right there, is to do that. Okay? And it's going to have 3 steps to this problem. 3 steps. I know, they're kind of long. So let's go ahead and let's get started. Let's do 1. Number 1. So we're going to solve. We're going to solve. Here we go. Let's do this one. Let's do kind of an easier one first. 5, 3, 3, 2 times x equals 1, -3. Okay, sometimes when you can solve an equation without even really knowing any algebra. Like I might be able to give this problem up here to my son and say, what's x? And he can go 2 times what equals 10? 5. And he doesn't know that you have to divide or anything. With matrix equations like this, it's really almost impossible to figure out what that matrix is going to be to multiply because matrix multiplication is so complicated. All right, so here's what we're going to do. This is matrix A. This is matrix B. Okay? And what we're going to do to solve is we're going to do A inverse times B. That's always your job, is to do A inverse, the inverse of this first matrix, on the left side of this matrix. So our first step is we have to find the inverse of this matrix right here. Okay, so here we go. First, find the determinant of matrix A. So the determinant of A right here is 10 minus 9, which equals 1. If you get 0, then you don't have to do anything at all, and you just say there's no solution. But they don't do that a lot. Okay, so now we're going to take 1 over 1. So our 1 divided by our determinant. And we're going to switch the 5 and the 2. So 2, 5. The 3's stay put, but they become negative. So that, do you agree, is the inverse of A? Yes, that's the inverse of A. And we're going to multiply it on the left side of B. And that's going to solve X for us. So this is A inverse right here, and then this is B. So you find the inverse, and now we're going to multiply these two together. Okay, here we go. That's why it's really important that you're pretty good at multiplication by now. So this is a 2 by 2 times a 2 by 1. So we're going to go across and down. Okay. We go 2 times 1 is 2, plus negative 3 times negative 3 is 9. Okay. Do the other one. Across and down. Negative 3 times 1 is negative 3, plus 5 times negative 3 is negative 15. And so the answer is 11, negative 18. Done. Okay? So 3 steps. Did you see all 3 steps? Step 1, find the determinant of A. Step 2, find A inverse. Step 3, do A inverse times B. And you're done. All right, let's do one that involves a fraction because those get a little tricky. Okay? So here we go. Let's do this one. 4, 3, 2, 2 times matrix X equals negative 5, 2. Okay. So let's go over this again. This right here, this first matrix is matrix A. This matrix over here is matrix B. In order to solve for X, I'm going to do A inverse times B. A inverse, this one inverse, ew, I don't like that at all, times B. Why doesn't it like that? There we go. Okay, so I'll do this one with you because it has a fraction in it. It gets a little tricky. So the first thing we need to do is we need to find the inverse of matrix A. So let's find the determinant of A. Determinant is 4 times 2 is 8. Minus 2 times 3 is 6. So the determinant is 2. So we're going to go 1 divided by 2. So 1 over the determinant. Switch the 4 and the 2. And then the 3 and the 2 stay put, but they become negative. So that right there is A inverse, the whole thing with the 1/2. Don't distribute the 1/2. I'm going to talk about that in just a minute. And then over here, I'm going to multiply this by matrix B. B's on the other side up here. Okay? All right, so whenever you have fractions, my suggestion, you don't have to take it, but my suggestion is this. Multiply the matrices first, and then at the end, multiply by 1/2. Okay? This one wouldn't have been so bad, but you will have negative 3/2, and nobody likes to do fractions, right? Especially when you have to do this by hand, right? So leave the fraction alone. Multiply the matrices together first. So we're going to leave the 1/2 out front, and we're going to multiply our matrices together. So here we go. You're getting pretty good now at multiplying, huh? We'll go across and down. So we get 2 times negative 5 is negative 10. Negative 3 times 2 is negative 6. Okay? And then do it again. Across and down. And that would be negative 2 times negative 5 is 10. And 4 times 2 is 8. All right, so now we have, bless you, 1/2 times negative 16 and 18. One last step. Multiply by 1/2. And our answer is -8, 9. Fun, right? Aren't these good?
Yeah, yeah.
I thought so. I thought you would think
I
that.
don't know why.
You feel pretty comfortable with that? Pretty confident? Okay. All right, let's move to the last part and then we're done. And this is going to be exactly like the first part. Just one little teeny tweak. All
I
right.
tasted ice cream when you said that.
Oh, ice cream? I love ice cream. All right, systems. We did in first semester, we did a whole chapter on systems. Do you remember what systems are? It's when you take two equations like this, x minus 2y equals 5, and 3x plus 5y equals -14, and we solved that. Do you remember solving those? You guys did a really good job on that chapter, I remember. Because you know why? Because you did this in Algebra 1, and you were kind of in Algebra 1 probably. It was a little hard. But then when you got to Algebra 2, you were 2 years smarter. You knew how to do them. We solved these by graphing, which everyone hates. We solved these by substitution. Remember solving these by substitution? You solved it, you plugged it in. And we also, does anyone remember the last way? Elimination, good. Okay, guess what? We're not going to do any of those. No. We're going to solve these using, what's this whole chapter on? Matrices. Yes. Okay. So this is a system and it's not a matrix. So first thing you need to do is you need to rewrite this in its matrix form. I'll show you how to do that. It's pretty simple. Okay. First thing you're going to do is you're going to take all the coefficients. Do you remember what coefficients are? Coefficients are the number in front of the variable, and you're going to make what's called the coefficient matrix. Coefficient matrix for this system right here looks like this. 1, that's the number in front of x. -2 is in front of y. 3 is in front of x, and 5. Okay? So just the numbers in front of the variables that you see up here. Now, the next equation is called the variable matrix. So what are our variables in our system? There's two variables, x and y. And if we multiply these together, do this in your head. Go across this row and down this column. What does this equal? 1x minus 2y. What does x minus 2y equal? It equals 5. And what does 3x plus 5y equal? -14. And this right here is called the constant matrix because those numbers are just constants. So coefficient, variable, constant. Now you do need to know those terms, okay, because I do ask you for that. In your homework, it says identify the coefficient matrix, and that's all you have to do. All right, here's what we're going to do, though. We have to solve for x and y, and take a look at this. This right here is just like matrix A. And this right here is just like x is what we're solving for. And this over here, bless you,
Thank you.
is matrix B. So all we have to do is exactly what we just did. We have to find A inverse times B, and that's going to give us, that will equal xy, which we can then write as a point xy. Whew. All right? It's exactly what we've been doing, though. It's just it's in system form to begin with, but then we write it in matrices and we do the same thing. All right, so maybe let's just do 2 to see how you do on these, okay? So here we go. What number are we on? 3? All right, number 3. And this has been 34 minutes. Well, we kind of paused and stuff. All right, here we go. Solve using matrices. 2x plus 3y equals 11. And x plus 2y equals 6. All right, there's a system of equations. For me, if I were asked to solve this, like I'm out, out and about at the grocery store and someone comes to me, can you solve this for me? I'd be like, yeah, sure. And then I'd probably use elimination because that's my favorite. But this is matrix chapter, so we got to do it by matrices. So here we go. Pretty sure that situation happens like every other week, not too often. All right, here we go. 2, 3, 1, 2. Do you see where I got those numbers from? Yes? They're the numbers in front of the variables. Okay. Next to that is the matrix XY. We're trying to find out what X and Y are. And then our last matrix is 11, 6. Okay, but it's the exact same thing we just did in part A. We're going to find the inverse of this first matrix, multiply on the left side of the other matrix. Okay, so here we go. Let's start. Let's first find the determinant of this matrix A. Determinant is 2 times 2 is 4, minus 3 times 1 is 3. Determinant is 1. Ooh, you're going to like it when the determinant is 1 or -1 because then there's no fractions at all. Did you lose something?
No, I forgot something was about those class.
Oh, okay. I'll let you go in just a minute, okay? Well, I don't want you to interrupt. All right, so take the 2's and switch them. Did I switch them or did I leave them? It's hard to tell. All right, and then take the 3 and the 1 and leave them and put negatives there. There you go. 11, 6. Okay. So there's your inverse, there's your determinant, there's your inverse, and now you're going to multiply. So we're going to go across and down. So 2 times 11 is 22, plus -3 times 6 is -18. And then across and down, -11 plus 12. And so what we get, we're solving for X and Y. What we get is, what is that? 22 plus -18, 4. And -11 plus 12, 1. So our answer is the point 4, 1. That's where those two lines intersect. They intersect at 4, 1 on a graph, if you were to graph them. Isn't that cool? You can use matrices to solve that system. Back in the day, we used to do a project. We'd give them, we had 5 ways to solve a system, and they had to solve a system all 5 ways and then write a paper about which one they liked the best, the least, which one worked, and da-da-da. It was awesome. Oh, it was great. Yeah, they hated it, so we got rid of it. Okay, let's try. You want to try one now? Yes. After all this is the last problem. You're going to try it. Okay, here we go. If you can do this, you can do the whole lesson. Are you ready, CS?
Kind of lost, but
I know, you gave up. It was sad. I saw it happen, too. Say something, I'm giving up on math. All right, 3x minus 2y equals 3. All right, you try this, okay? Great, but all right. Yeah, fractions. I love fractions better than decimals, so. All right, let's set it up. Here we go. If you can set it up, you know, you're getting there. You're halfway there. Maybe not halfway. And then you get 4, 3. All right, so here we go. We're going to do the whole thing. 3 things. You first have to start by finding the determinant. The determinant is -10 minus -12, which is 2. Okay? So we're going to do 1 over the determinant. Okay, we're looking at this one right here. We're finding the inverse of that matrix. So you pick up 5 and -2 and you switch them. -4 becomes +4 and +3 becomes -3. And you put that on the left side of 4, 3. Okay? If you can do that, that's great. That's actually not the hard part. The hard part's coming up, right? The multiplying part. So we're going to go across and down. And I'm going to leave the 1/2 out there. I don't want to deal with fractions. So I'm going to leave 1/2 there. And I'm going to go across and down. So I get -8 plus 12. Yeah? So -8 plus 12. And then this one right here, -12 plus 15. What did I do? We're okay? So then I get 1/2 times, now don't forget what we're solving for. And I usually forget to write that, but it's okay. So then I get -8 plus 12 is 4. -12 plus 15 is 3. And then go ahead and multiply everything by 1/2. So you get 2. Did you just leave it as 3 halves? Or 1.5? 1.5? Okay. So So then our point, and you really should list it as a point at the very end because that's what we're solving, is 2, 1.5. Who got that? Good, good. Then you're good. You got it. That's the whole lesson.